Hello everyone, welcome to another pre-algebra with Professor V. So today we're going to look at divisibility tests, okay? Knowing whether something is divisible by 2, 3, 5, 6, or 10 is really super intuitive and helpful, okay? Um, this looks a little bit odd, you might be thinking, why would I care if something's divisible? Like, they're not asking me to divide, right? But this is the technique that we use when we're simplifying fractions, okay? So it's just good to know if we could divide by 2, right? So if you've ever experienced fractions, you know you have to, the top and the bottom have to have the same factor, right? They have to be a factor of 2, so I could divide by the bottom and top by 2, right? Something like 2/4, right? It is a pretty basic one, right? But I know I can divide both by 2, right? You need to be able to see the divisibility in order to simplify it, right? I'm not going to go over this too much. This is confusing, it's fine. But I am showing you that this does have application further down the line, okay? So this skill really is a good one to learn. So when we're looking at 96, right? Let me put it a little more to the left because I feel like I might need more room. Okay. So I'm looking at 96. I already know it's divisible by 2. How do I know that? Because all even numbers, right? 2, 4, 6, 8, 10. And I ask many students, especially the younger ones, right? How do you know something's even? And they just start counting, right? And it's not bad, but what I really would like you guys to see is there's a pattern, right? And the pattern is in the ones position, right? 2, 4, 6, 8, 0, right? 2, 4, 6, 8, 0, right? Now it does changes the tens position, but it's irrelevant. This is truly what makes things even, this pattern, right? 2, 4, 6, 8, 0. Well, I already see a 6 right here, right? So this must be divisible by 2. Okay, so I'm going to go ahead and erase this. Give me just a moment. Now the three is a fun one. So here's how you could check if something's divisible by 3. I love this stuff. Goes into a lot of numerology and whatnot. So 9 plus 6. So what you do is you take the digits and you add them. And we end up getting 15. So this is also divisible by 3. So far, this is divisible by 2 and 3. And you might say, why is it divisible by 3? Because 3 will fit into 15 5 times. And you might not believe it, so let's just do it, right? 3 into 96 fits in 3 times. 3 times 3, 9, right? I'm going to kind of fly through this because we don't have all the time in the world. So 2. So it fits in evenly, right? And so does the 2, right? We could do 2 into 96 as well. So I proved that one to you guys too. That's 4. That's going to be 4 times 2, 8. 1, that's 16, so that's 8. So 48. So these things are divisible. Okay. So far we have 2 and 3. And if I remember the rule correctly, that means it's divisible by 6 as well. And why is it divisible by 6? Because 2 times 3 is 6. So if your factor can be simplified by 2 and 3, then it means that 6 also works. But let's go ahead and prove that one. It's been a while since I've done the divisibility by 6. So that fits in once, right? That's 6. That'll be 3, 6. So it does fit into 6 as well, okay? So now, the last thing that we need to check are 5 and 10, but it's not divisible by 5 or 10, right? So there's also a pattern when counting by 5s, right? It's even easier, whoops. It's even easier than the evens, right? 5, 0, 5, 0, 5, 0, 5, 0, all the way, right? No matter what, if you're counting by fives, your ones is always going to have 5 and 0, okay? So, no way will I ever get to 6, right? I cannot get to 6 in this ones position. And tens are even easier because they always end in 0, right? That's their pattern. So if we count by tens, nothing but zeros. So 96 is only divisible by 2, 3, and 6, right? Okay. So we did 413. So now let's look at 414. So 414 is 250. And hopefully you guys are at least seeing the 10. The 10 screaming at me, it is like I am divisible by 10, right? And if you don't believe it, I could prove it real quick, right? 250. This will fit in twice, that's 20. Bring down the 50, that's 5, right? So it fits in evenly. What's also going to fit into this evenly is 5, right? So 5 will fit into 250. 5, right? 25. 0, bring down the 0, fits in 0, so it's 50. Now, what other numbers do we see? Let's see. I see 2 for sure, right? 2, 4, 6, 8, 0, 2, 4. I see the 2. But what about 3? Well, to do 3, we have to do 2 plus 5 plus 0. And then we get 7, right? Well, 7's not a factor of 3, right? I can't go 3, 6, 9, right? I can't ever land on 7 if I'm skip counting by 3. So factors of 3 do not include 7. So it's not divisible by 3. Which means it's not divisible by 6, right? We would need 2 and 3 here for it to work. So these three numbers are the only divisibility. These are the factors that we could divide by. That's the divisibility check right there. So now we have on 415, 420. And hopefully you guys are starting to see, right? This will be divisible by 10 and 5 right away, off the bat, right? 10, 20, 30, 40, it ends in 0. 5 also ends in 0, right? 5, 0, 5, 0. Now we check for 3, so 4 plus 2 plus 0 equals 6. So this thing's divisible by 3. Because 3 is a factor of 6, right? 3, 6, 9, right? It does land on 6. Should have not put the 3 there yet, but anyway. This is also divisible by 2, right? 2, 4, 6, 8, 0. So, and since it's divisible by 3 and 2, guess what? It's also divisible by 6, right? And the 6 I want to at least prove. I also find that fascinating that this works, but anyway. So that's 6 and 6 is 36, so that's 7, right? Because that's 42. So it looks like it's going to fit in 70 times. And, you know, being able to see these divisibilities will help you so much with fractions later, okay? But anyway, so let's keep moving. This video is getting a little bit longer. So anyway, 625, right? So right off the bat, I hope you see the 5, right? 10 in this case, no, right? It does not end in 0, but it does end in 5. So we could check. So 2's also are out, right? 2, 4, 6, 8, 0, right? 2, 4, 6, 8, 10, right? Well, I can't ever count by 2's and land on something with a 5 in the ones position. So we can check the 3's. 6 plus 2 plus 5. So what does this equal? 8, 9, 10, 11, 12, 13. Well, 13's not a factor of 3, right? So 3, 6, 9, 12, 15. I can't ever count by 3's and get to 13, so 3 is also out of the table. Since 3 and 2 are out of the table, that's also 6. So then in this particular case, this number is only divisible by 5. So This is the divisibility check. If you would like a deeper explanation of it, please let me know. There's a lot of practice problems on the OpenStax book that I can crack into and show you guys. If this brought value to you, please like and subscribe so other people can see it. And if you have problems with this or other ones, comment down below. Other than that, I will see you in the next video. You guys have a great day.